Hi guys, welcome back to another Mr. Hutton Science tutorial video. Once again, this is to go with your AQA GCSE chemistry course, and today we're looking at percentage yield. So let's make sure we're ready. Phones are away, you've been to the toilet, you've got yourself a drink and pen and paper, and you're ready to go. So what is yield? Yield is the amount produced of an individual species in a reaction. So for example, if 30 grams of iron was produced in a reaction, the yield for that reaction would be 30 grams. Previously, we've been looking at using balanced equations and the reacting masses calculations to determine the mass of products when we know the mass of reactants. Okay, so when we are calculating reacting masses, what we're actually doing is we're calculating the theoretical maximum yield for a particular species based on the other information in the question. Okay, so when we're looking at X grams of Y reacting with Z grams of W, you're actually calculating the theoretical maximum. Okay, in industry and in real life, very rarely are you going to get the actual value that you've calculated, and there's many reasons for that. Okay, some of those reasons are that you lose some of your product during transfer. Sometimes you get impurities, so you get unwanted reactions going on, reactions you weren't expecting, so you don't get the products you're expecting. Sometimes you have reversible reactions, so where the products are then breaking down back into reactants again. So very, very rarely are you ever going to get an exact amount that you were predicting as your product. Okay, so you use the term yield as the maximum amount you would get from a reaction. So percentage yield, okay, slightly different. This is when we look at how much we thought we were going to get and how much we actually got, and we look at that as a percentage. Okay, so the percentage yield is a way of expressing what percentage of the expected yield you actually got from your reaction. So if the theoretical maximum reaction was 100 grams of iron, but we only got 30, then the yield would be 30%. So based on what I've said there, based on that statement, do you think you can actually come up with an equation for percentage yield? I mean, how have we worked out 30% from that information? Okay, so take a moment now, you can pause the video, have a moment to think about it and see if you can come up with an equation for percentage yield. Okay, right, so hopefully you've come up with an equation similar to mine here. So we take the actual amount that we got over our theoretical maximum times 100 to give us our percentage yield. So for example, in the example above there, we expected to get 100 grams, we only got 30 grams, so 30 divided by 100 times 100 gives us 30%. Right, let's look at a few questions to really embed this. Right, question 1. The company calculated they would produce 1.2 tons of magnesium, but only 0.9 tons was produced. Calculate the percentage yield. So using our equation, the actual amount divided by the theoretical maximum times 100, we can then put the figures in. The actual amount was 0.9 divided by the theoretical maximum, which is 1.2, times 100, 75% percentage yield. Okay, let's look at the next question. So a different scientist makes zinc iodide by the same method. The scientist obtains 12.5 grams of zinc iodide. The percentage yield in this reaction is 92%. What's the maximum theoretical mass of zinc iodide produced? Okay, so this time we're turning things around a bit. We've been given what they obtained, and we've been given the percentage yield, and we have to try and work out the theoretical maximum. So we still use our same equation to start with, so the actual amount divided by the theoretical maximum times 100, but we have to now manipulate this and rearrange it to make the theoretical maximum the subject of our equation. So if we do that, we then have the actual amount divided by the percentage yield times 100 gives us our theoretical maximum. So again, we just put the figures in from the question. The actual amount is 12.5 grams. The percentage yield is 92, so 12.5 divided by 92 times 100 gives us 13.58. Now then, in this question, you can see that the 12.5, that's 3 significant figures, 92.0, 3 significant figures. So we really need to give our answer in 3 significant figures. So we need to just change that slightly to 13.6 to 3 significant figures. Okay, another question here. This is a 2-part question. So the first part, okay, we've got part 1 and part 2. The first part is a reacting masses question. So I've just thrown this in here to see if you can remember about reacting masses. If you're unsure about reacting masses, then go back, look at the reacting masses video, and then come back to this. So part 1 is reacting masses, and then part 2 is a percentage yield question. Alright, let's look at part 1 first then. So it says the student wants to make 11 grams of copper chloride. The equation is there. Calculate the mass of copper carbonate the student needs in order to get 11 grams of copper chloride. So really this one, all you're going to do is work out the moles of the copper chloride. It's 1-to-1 reaction. You can then multiply the moles by the MR of the copper carbonate to work out the mass of the copper carbonate. Okay, like I said, check out the reacting masses video if you're unsure about this, but I'm going to quickly run you through it here. Right, so we've got 11 grams divided by the MR of copper chloride gives us 0.0818 moles. It's a 1-to-1 reaction, so we'll have the same moles of copper carbonate. Copper carbonate has an MR of 123.5 multiplied by our 0.0818 gives us 10.1 grams. Okay, part 2. The percentage yield question. The percentage yield of copper chloride was 79.1%. Calculate the mass of copper chloride the student actually produced. Now, if you remember back to the question, it was talking about 11 grams. Okay, so that's something that you need to remember for this part. And again, we're going to use our actual amounts versus actual amount over theoretical maximum times 100. So if we put the numbers in, we have to rearrange it first, so we haven't quite got the equation we need to rearrange it first. So if we rearrange that, we get percentage yield divided by 100 times theoretical maximum equals the actual amount. Now then, if you're unsure how to rearrange equations, you need to go and ask your teachers about that, or hopefully in the future I'll get a video out about rearranging equations, but I haven't got that yet. So if you're unsure, then go and ask your teachers, parents, tutors, just to help you with rearranging equations. Right, so we've got the equation we need there, and let's just plug in the numbers from our question. So 79.1% we can see in the question just there, divided by 100 times 11 grams, which we got from the first part of the question. It told us there that they were making 11 grams, would equal the actual amount. So 79.1 divided by 100 times 11 equals 8.70 grams. And again, we're to 3 significant figures because that's the numbers that were quoted in the question. They were to 3 significant figures. Okay, right, so again we've got another question here where we've got 2 parts to it, so part 1 and part 2. We're going to look at part 1 first. So the teacher's using 1 gram of magnesium, calculate how much the maximum mass of magnesium oxide produced. So again, a reacting masses question. Go and look at the video if you're unsure. If the last question we looked at you didn't quite follow, then again, watch the reacting masses video and come back to this. Okay, the second part of the question is a percentage yield part where we need to use the answer from the first part. So that's quite important. And do note there, this is an exam question. It does say if you couldn't do the first part, then it does give you a number to use. Okay, it says to use 1.82 grams in part B if you couldn't do part A. But, you know, that's not actually the answer. So don't get worried if you've worked out the first part and you're not getting 1.82 grams. Okay, that's just a number they give you in order to help you if you couldn't do the first part. So let's look at part 1. Right, so it says here the teacher's got 1 gram of magnesium. Use the equation to calculate the maximum mass of magnesium oxide produced, so the MgO. So again, reacting masses equation. we need to use our mass over mR equals moles. So the mass we've got is 1 gram of magnesium over the mR of magnesium 24. Well, strictly speaking, it's the AR because it's an element. So that equals 0.0417 moles of magnesium. It's a one-to-one reaction. So we just do 0.0417 times 40, which is our mR of magnesium, to give us 1.67 grams. The teacher used 1.00 grams, 3 significant figures. Okay, so we're quoting as 1.67 again. Okay, part 2. So we're going to use our part 1 answer. So we've got our part 1 answer at the top there, 1.67 grams. And it says use your answer from part B to calculate the percentage yield. So the teacher produced 1.5 grams. Okay, the theoretical maximum is 1.67. They got 1.5. So let's use our equation again. Actual amount divided by theoretical maximum times 100. Plug the numbers in. 1.50, the actual amount they got. 1.67, what we calculated they should have got, times 100 equals 89.8%. Okay guys, that is percentage yield. Go away, try some questions on percentage yield. If you're unsure, drop me a line or go see your teachers. But look out, set your notifications for the next Mr. Hutton Science video.